We're gonna do a lab prep. Thursday, we're gonna do a lab. That lab won't be due until Monday for you guys, thank you, because you have a quiz on Friday. So when you go home on Thursday night, I don't want you worrying about the lab, I want you worried about, getting ready for your quiz.
Wait, the lab won't be due till Tuesday, right?
Tuesday, thank you, yeah, because Martin Luther King Day, yeah, won't be due until Tuesday. That sounds right. And then you will have no tests or evaluations the last week of school, okay? Yep. So basically, last two grades are gonna be quiz on Friday, lab due on Tuesday. Okay. All right, so let's, I'll take you through one of these from the other day, and then we'll try and get you to do one each, one acidic, one basic.
You don't put in the bonus for last time.
The bonus, again, bonus is gonna be at your discretion. So when I sit down with you, remember at the end of every quarter, I sit down and talk with you about your grades?
I mean the food drive.
That's what I'm saying.
Oh, okay.
That's at your discretion. So I'll sit down with you at the end of the quarter, probably next Friday, and I'll say, okay, here's what I got for a grade, here's what I'm thinking about recommending you for next year. Do you want to use your bonus points or not? So you're not forced to use them. So say you got an 86 right now. You might just say, keep them in the bank. You know? Because typically I have one more bonus point opportunity when they do the pennies for patients. There'll be a thing there too, so you have a chance to get some bonus points. So if you want to save them, save them, you know? But it's all or none. You either use them or you don't. It's not like, well, I'm going to use 3. I'm going to save 3 for I'm not going to keep track of that crap. So. Okay, so let's look at 76A. I'll do one for you, and then we'll send you guys up to do some. 76A is chromium plus the chromate ion, CrO4, CrO4 plus 2. Yielding CrOH, Cr parentheses OH parentheses 2. Okay. Another thing to keep in mind if this one is basic. Remember, if you're acidic or basic, that tells you how you're going to approach it. You do both exactly the same in terms of you do them both exactly like you do acidic, except basic you have an extra step, adding OHs in. So I'm going to look at this. Atom of an element, oxidation state, 0. By rule, oxygen is -2. And so if there are 4 -2s, that's -8. If this has to tally up to -2, then this must be +6. Okay, now this can get tricky, but we have some rules here. O is what? H is +1. And think about it like this, too. OH, isn't this -2 and this +1, and doesn't that add up to -1? So you can look at it in terms of the polyatomic ion, or I could just do it based off of the rule. So if this comes out to be -2 and 1, then that whole thing is -1. And if you got 2 of them, that means this thing must be +2. So figuring out oxidation states is crucial. If you can do that, then a lot of it gets a lot easier. So here's a weird case where 2 things are connected to the same thing. So this chromium is connected to this chromium. And this chromium is also connected to this chromium. So you got 2 things connected to the same thing. That's not a problem. Now, remember, reduction is a little easier to see. Number goes down, that's reduction. Because reduction, remember, oil rig, reduction involves gain. If you gain negative electrons, the oxidation state will go down. If I'm getting negatives, I go down. Oxidation, oil, is oxidation involves loss. If I lose negatives, I become more positive. So if I lose electrons, I become more positive. All right, so I have oxidation and reduction. Okay, so I like to do oxidations first. So I'm going to put down chromium going to chromium, what would this be? Chromium 2 hydroxide. And then over here, my reduction reaction, I have the chromate ion, CrO4 -2, also going to chromium 2 hydroxide. Okay, so I got 2 things that are quite similar. Okay, start out balancing all elements except hydrogen and oxygen. Well, that leads me to chromium here, and they're already balanced. Yes, sir?
Chromium hydroxide is 3.
Oh, 3. Thank you. That makes a big difference. So that changes that, and that changes this, doesn't it? So what would this be? These are -1, and there's 3 of them? +3. Thankfully, it didn't change our oxidation and our reduction, so thanks for those part is probably making a mess out of it. Okay, so that means that this should also be 3. So it's chromium 3 hydroxide, not chromium 2. Good there with all my screw ups. So we changed it. Here, here, there. Okay, first step, balance everything but hydrogen and oxygen. So in this case, the only thing that's in here is chromium. And there's 1 chromium and 1 chromium, we're already good. Over here, same thing, the only thing it's to look at would be chromium at this point. Chromium and chromium, there's 1 and 1, we're good. Okay, now we're down to hydrogen and oxygen. What do we do first?
Oxygen.
Oxygen. Why do we do oxygen first?
We use H2O.
And that brings in?
Hydrogen.
Good. So we're going to do, when we balance oxygen, we're going to balance it using H2O because this is an acidic solution. There's going to be water there. When we bring in H2O, we're also bringing in H's. So you might as well do that first before you mess with the H's because you're going to screw them up when you bring in that. So I'm going to have to bring in 3 H2Os to balance this up. So 3 H2Os brings in a total of 3 H's. Over here, I'm going to do the same exact thing. I'm going to bring, oh no, I'm not, because there's 4 oxygens here, there's 3 here, so I'm going to bring in 1 water on this side. CrO4 -2 yields CrOH3. So 4 O's, 3 O's, bringing in H2O, and that's going to bring in 1 more O. So we got 4 on both sides now. Balance out my H's using H+. Even though it's an acidic solution, we're going to go at it like it's, even though this is in a basic solution, we're still going to approach it like it's acidic initially. So I've got 6 H's here, I've got 3 H's here, I need 3 more on this side. So 3 H2O has 6 H's. CrOH, parentheses 3 is 3, so I'm going to bring in 3 H+ over here. In this one, I've got no H's over here. I've got 3 H's plus 2 more H's. I've got 5 on this side. So I'm going to bring in 5 H+ over here. Okay. Now, here's the extra step, right? You're not allowed to have H+. It's not an acidic solution. It's a basic solution. So we're going to add an equal number of OHs as H+s to both sides of the equation. That's the thing where most guys screw up, is not doing it to both sides. So if I add 3 OH here, negative, that's going to become 3 water molecules. But don't forget to add 3 OH over here. And over here, I'm going to add 5 OH to make that 5 water molecules. And don't forget to add 5 OH over here. Yep.
So why do you add the OH again?
Because you're in a basic solution. You're not allowed to have H+. That's an acidic thing.
Okay.
So I'm going to rewrite what I got here. So what I've got here right now is 3 OH plus 3 H2O plus Cr yields Cr parentheses OH parentheses 3 plus 3 H2O. So I just rewrote that. And now I'm going to look at charge. 3 negatives, no charge, no charge. So this is -3. No charge, no charge. I'm going to add 3 negatives to this side. So now I've got my charges balanced. I'm going to rewrite this one as 5H2O plus CrO4 -2 yields Cr parentheses OH parentheses 3 plus H2O plus 5OH minus. Let's see, I've got 2 negatives here, 5 negatives here, so I need 3 electrons on this side, and that makes this -5, and that's -5. Yep.
On the octave pad, can you have an OH from the very beginning? Because you see on the right. Skip on
I'll tell you this, it might work on occasion, but I wouldn't go that route, because it's gonna screw you up. Okay, now that turns out to be nice and pretty, doesn't it? Why is that pretty?
Because you're adding in 3 electrons to
The both, so we don't have to inflate or, we don't have to mess with any of the equations, we just gotta combine them. So, gosh, it's a horse apiece which one I move, so maybe I'm gonna move this one over here. So I have 3OH minus plus 3H2O plus CR yields CR parentheses OH parentheses 3 plus 3H2O plus 3 electrons. Combine those two reactions. By the way, before I do that, how many zombies are going to be in here tomorrow because you stayed up too late watching the national championship? None of you guys? No? Okay. I just figured some of you guys would be up late watching the game. No? Who doesn't even care? Huh? Okay. What if it were Notre Dame? Who would care? Okay, there you go. All right, so again, what we're going to do is anything that occurs identical on either side of the equation will cancel out. Anything that's on the same side of the equation that is identical, you're going to add them up. So let's start out with the electrons have to go away. That's kind of the whole deal here. Electrons have to go away. Let's see. I got 5 and 3 waters on this side, and I have 4 waters on this side. So there's a couple ways you could do it. We could say, let's get rid of that one and that one, because they're easy to cross those two out because they're both exactly the same. And then I can get rid of this, and maybe I cross this one out and reduce it down to 4H2O. I also got some OHs I can get rid of. I got 3 here, and I got 5 over there. So all 3 of these go away. And 3 out of these 5 go away, leaving me 2. So do you see how in these problems you start to get a lot more canceling going on? Yep.
cancel the H2Os on top and then the 3 H2Os on bottom.
Because they're all one reaction. We split them into half reactions to get them balanced, so they're still part of the same thing.
Like, in this situation, if we just added the 5 H2Os and 3 H2Os and then just subtracted the right side.
That's perfectly fine. Yep. I like it. The reason I like doing it the way I did it was because then I could just get rid of that and say I don't have any other mess, you know. But yeah, you can do it like that. So what are we left with? We're left with 4H2O. 4H2O plus CrO4 -2, nothing, and chromium plus chromium yields. Now, do you notice that we didn't cancel these two, right? What do?
Yeah.
They add, because they're on the same side. So this is going to become 2 Cr parentheses OH parentheses 3. Nothing. I got 2 OHs here plus 2 OH minus nothing. So that's all I'm left with. Does it work? Let's see. 8 hydrogens. 2 times 3 hydrogens is 6, plus 2 times 1 is 8. So then we got 8 total hydrogens. Oxygens, we have 4 here and 4 more here. So we have 8 oxygens, same thing, 2 times 3 and then another 2. We got a chromium and a chromium, chromium and a chromium, 2 times chromium. And then this side all adds up to -2, that side adds up to -2. Does that work out okay? Yep.
So if our electrons are on different sides, then we do something.
Exactly. Everybody hear that? If your electrons don't show up on opposite sides, you screwed up. You know, that's like, how would you do it? That's like not me losing $20 and you finding the $20, like a trade of $20. It's like it's both losing $20 or both finding $20, which is not. There's not an exchange then. And this is what these are all about: is exchange of electrons. Okay. Neatness is important, right? Yep.
Like, how did you pair them up at the end? Like, I'm not seeing it.
How'd I pair up?
Like the top, like the 2 lines above your answer.
Okay, so here's my thing here. Do you get the canceling?
I get the cancer. How do you
Okay.
pair them up?
So I said, here's 4H2O. Here's my chromate. Here's my chromium. That went away, that went away, that went away.
No, I got that, like, where, did you just take all the products and all the reactants?
All the reactants and all the products, yeah. Same thing here, so these two combine to make this. Gone, that comes down, gone, gone. Good. All right, so let's get you guys up here. You can do some. Ideally, I would like to get through an oxidation, acidic anabasic today. Let's do you guys to do a basic first, as we did an acidic the other day, and this is 75, or 76, right? 76.